Good morning, guys. This is Yash Shetty from 5th Sem CSE C section, and today we'll understand the concept of Turing machine with the help of JFLAP. So first, let's see what is Turing machine. Turing machine was first invented by Alan Turing in 1936, and it is used to accept recursive enumerable languages, that is generated by the type 0 grammar. A Turing machine consists of a tape of infinite length on which read and write operations can be performed. The tape consists of infinite cells on which each cell either contains input symbol or special symbol called blank. It also consists of a head pointer which points to the cell currently being read, and it can move in both directions. That is, this tape can move either left or right. So a Turing machine is expressed as a 7-tuple Q, T, B, sigma, delta, Q naught, F, where Q is a finite set of states. Q is a finite set of states. T is the tape alphabet, symbols which can be written on tape. B is the blank symbol. Every cell is filled with B except the input alphabet initially. Sigma is the input alphabet, symbols which are part of the input alphabet. Delta is a transition function which maps Q cross T to Q cross T cross LR, depending on its present state and the present tape alphabet pointed by the header pointer. It will move to new state, change the tape symbol, and move header pointer to either left or right. Q naught is the initial state and F is the set of the final states. If any state of F is reached, input string is accepted. Regardless, if it does not reach an accepting state, then it is rejected. Now, let us take an example of this Turing machine that accepts L, which is of the form 0 to the power 2n, where n is greater than equal to 0. Here you can see that we have 5 states: Q0, Q1, Q2, Q3, and Q4. And I'll just show an example. Uh, First, we'll take a case that will get accepted by the Turing machine. That is 0, 0, 0, 0, and it ends with a blank symbol B. I'll click on OK. So initially, the start state is the Q naught state. That is the initial state is the Q naught state. Now, if we go to the next step function, it will go to the Q1 state by changing the B to blank state, and it moves to the right, as shown here. This is the tape. Now, next on clicking step, we see that the input was 0, so we change it to X, and we move to the right. That is, we again point to 0. Clicking on next, we go to the state Q3, and we do not change the 0 and keep it as it is, and move to state Q3 and move to right. Clicking on next, we go to the state Q2, where we replace the 0 with X, and we move to the right, that is B. Now when we encounter B, we move to the state Q4, that is the final state, and we have reached the end of our input alphabet. So as this ends in an accepting state, this given input will be accepted. Now if I take a new example where this should not work, like 0, 0, 0 and B, let's click on OK. So the start state is Q0. On clicking next, it goes to Q1 and changes the 0 to B, that is a blank symbol. Clicking on next, it changes the 0 to an X, going to Q2, and then it goes to Q3. And now Q3 has no state which goes on input B. That's why if we click next, it won't do anything. So this indicates that this string has been rejected, and hence you can show that our uh, Turing machine works perfectly fine. Thank you, one and all.